Bem-vindos to one more episode of the Type Theory for All podcast. As always, this is your host, Pedro Abreu, and in today's episode, we talk with David Christiansen. He wrote the books Functional Programming in Lean and The Literal Typer. He has also worked as the executive director of the Haskell Foundation at Galois, and he did his PhD developing a bunch of cool stuff for Idris. David is a super upbeat person, and I feel that we could spend hundreds of hours talking about functional programming, writing, and dependent types. And we will still not run out of topics. This episode is brought to you by Formal Land, a formal verification company focused on verifying the implementation of programs with the cog-proof assistant. They have been working on the verification of Rust and OCaml code for the blockchain industry, in particular for Tezos and for Aleph Zero. So if you're looking to ensure an extra layer of correctness to your blockchain, take a look at Formal. Welcome everyone to one more episode of the Type Theory for All podcast. This is your host, Pedro Abreu. It's my great pleasure to be here today with Dan Blokin, and I got your name right this time, dude.
Yeah, I can't believe it. Congratulations. It's worth an award.
How you doing, bro?
I'm happy to be here. I can't complain. That's what you're supposed to say in the Midwest.
Well, you're going to have a really nice eclipse coming up, and I'm really excited for that. I don't know about you, but I am.
Yeah, I mean, I might have to miss it because of work, because of the, our wonderful academic lifestyle that we have. We love and hate it.
Fucking academia, dude. Fucking academia. Okay, so I will introduce our guest today, David Christiansen. Welcome to the show. Do we have that kind of problem in your current life of not being able to see cool things because you're too busy?
Absolutely. I've got a 4-year-old.
That must take all your time, huh?
No, but lots of it. But it's a good kind of busy.
Oh, yeah.
Yeah.
I can see that.
Yeah.
Good stuff. So, David, tell me, you've done a lot in your academic life, in your career. You've been executive director of the Haskell Foundation, worked on Galois. You're working on Lean right now. But I want to go right in the back, the beginning. My question is, how did it all get started? How did you get interested in type theory and functional programming languages? What's your story?
The functional programming came way before the type theory. And I think, speaking honestly, it's mostly that I was a bit of a hipster, I guess. I'm like, okay, I'm in my undergrad. I'm like, oh, the cool kids, they're doing Lisp. I better learn some Lisp. And like this Haskell thing, like it sounds totally out there, right? Like you can't even have side effects. You can't even mutate a variable. I got to learn this thing so I could be doing the cutting edge stuff. This is in the very early 2000s. So Haskell wasn't nearly as big and practical and popular back then as it is today. And the learning materials weren't as good. And, I could kind of hunker down and write programs that went way too slow because I really didn't understand what I was doing. And not any fault of Haskell, just the fault of trying to treat lazy lists as if they were strict lists and all these kinds of things, or even as if they were packed arrays. But, I had a real tendency to try to grab.
I think so many people, you called out so many of our listeners right now with that hipster comment. Me, absolutely.
Yeah. But then, functional programming wasn't the only of these things that grabbed me. I think fancy types and Lisp are the two sort of enduring legacies of that time. But I also had my, I'm going to go on eBay and get a machine that run Next Step and experiment with that. And I guess that was more of a late 90s project back before Next acquired Apple for negative big number of millions of dollars. But, I had my small talk phase, but the things that really stuck with me were Lisp and the broad sort of Haskell ML tradition of programming, and I guess that might be a sign that they're both really good, or it might be a sign that they fit my personality. I'm not really sure. But I think once I worked through a structure and interpretation of computer programs, and once I managed to write a Markov chain text generator, nonsense text generator in Haskell, I was hooked. I was pretty stuck on it.
Did you have classes on those things, with those books?
No.
More of a hobby thing then.
Yeah, so I did most of my undergraduate career at the University of Idaho, which was a very C++ oriented kind of place like some profs were probably more understanding and flexible than they should have been. In retrospect, I realized I gave them way too much work by giving them homework assignments in languages they didn't know and expecting them to grade them. But some of them were indulgent and let me do it, and others said, like, no, you got to do it in C++. So I did.
I think a sign of a very good professor is a professor that doesn't mind taking the extra work if if he sees the student is worth it. Like it's really trying their best and trying to learn something new.
Yeah.
I think it was.
I like it when that happens, but I don't think it should be mandatory. I know how busy they are, so yeah.
No, not mandatory. Yes, I agree.
Yeah, but
it's very nice.
But I actually ended up graduating with a major in philosophy rather than computer science. So I also didn't have that many CS classes. I had like the core curriculum and some upper division classes. Like I had the AI class, and that's when AI meant like A-star search and
right.
Implementing Prolog rather than like statistical models of machine learning like it does today.
So after that, you finished with a major in philosophy, and did you go straight to a PhD after that?
No, not at all. So, so I graduated with a major in philosophy, minor in computer science. And there's a really cruel joke they tell about philosophy majors, which isn't actually true. But, they say, like, how do you get an unwanted philosopher off your front porch? And the answer is pay for the pizza. Like, I probably could have gotten some kind of like programming job for fun, but I didn't have anything that like made sense. I'd have to move anyway because I was in a small town in Idaho, which is where I grew up as well. But I think like, what am I do? But I'd spent a semester abroad in Denmark, and the study abroad program I'd been on had an internship program. And so, I applied for that, and then I got to come back to Copenhagen and, spend a year like diagnosing Windows XP Wi-Fi connection issues on computers in all sorts of languages from students around the world. I did manage to like fix Wi-Fi issues for like Chinese language Windows XP at one point, which is fun.
Wow.
And like, going up and down a lot of stairs in this old building from the 1600s, carrying big boxes of paper to fill up the printers. And just like having a fun time living in Copenhagen, thinking like, that's a good way to spend a year before I figure out what I'm going to do. And then the internship kind of managed to turn itself into a job developing the course registration system. And for various technical reasons, this was a PHP app backed by FileMaker Pro, which is this database that probably a lot of listeners don't know, but it's kind of, I guess I'd put in like the same family as like Microsoft Access or something. But it was actually a really great tool that lets like small companies do really inexpensive, fairly usable custom database apps. And that's what this program had. And so that's what we had to put behind our website so people could sign up for their courses from home. And so we did, which was a bit of a technical challenge. But then, eventually we transitioned from that to a Django app. So I started writing Python full time and, working with Postgres. And, eventually, like this started being less fun than it had been. Like I kind of got to the point where I wasn't learning a lot of new things and where like I could learn new things, but it wasn't going to be in service of getting the job done. So I thought, okay, let's maybe think about what happens next. And my employer had been so kind as to pay for me to take some classes at ITU in Copenhagen. That's IT University of Copenhagen. As like if you're an EU citizen or if you have the right kind of Danish residence permit, then you can do a study program for free. But if you just want to take one class, you have to pay, as they paid for it, which was great. So I managed to learn a lot of great skills there, like usability, assessment of software, which was really important for the work we were doing there, and get some actual knowledge of databases rather than just like I'm going to use the ORM and things like that. But I thought, okay, it's time to go back and study. And if I wanted to get any other kind of job, Denmark is. By this point, I'd met the person who I'm now married to, and it seemed like Copenhagen had become home. And if I wanted to get a job here, it's like, well, I need a bit more of a credential than a philosophy degree from Idaho. Partly because master's degrees were still pretty new in Denmark at the time. They came in as part of the Bologna Accords, so a bachelor's degree was seen as like the stopping point for people who didn't finish for some reason. Like the consolation degree. So a bachelor's degree on its own wasn't that respected in Denmark. It's more so now, but now that they've existed for longer. But still, most people go straight to a master's here. And also, I needed to have something that said something more about like software development. So I thought, okay, well, I'll, sign up for ITU. So I went there full time. And that's how I got started. And then, I was interested in the research that was going on. I being a person with a lot of hubris and a total Haskell dweeb, I'm like, oh, there's a PhD course on category theory that I think I'll sign up for. which was one of my first absolute failure experiences in my life. Like working as hard as I could at something, like all day and all night, like staying up late, like trying to write the proofs and just not being able to. Not by any fault of the instructors. I was just sort of woefully underprepared for that course, and they were
Okay.
like they let me in.
What do you think you needed to be prepared for that course?
I think I would have needed to have the background information to have the illustrative examples in the textbook be things that I'd already seen rather than things I had to learn in order to understand the example.
Mm-hmm.
So like I would have needed to know some domain theory. I would have needed to know
Topology, maybe?
a bit more like algebra and order theory. They're like, oh, here's an example. This is an omega CPO. And they gave like a very concise definition. I'm like, I'd never seen that before at the time. So
right.
I was lost. But, I also did a bit of research work. I did some independent projects. I got to do some work with Thomas Hillebrandt and Marco Carbone and learn some session types. It was super fun. And, we ended up getting a little workshop paper put together when I was a master's student, and we went to present it. And Marco actually said to me on the trip, like, hey, why don't you apply for a PhD? It seems like you could be a fit. So I thought, okay. And so I did. And then that's the story of getting into the PhD. So there was like a 6-year gap between bachelor's and going back to university.
Wow. And when you applied for the PhD, you already knew Edwin and Idris?
No.
Because that's what you ended up working on, right?
I mean, yes, but I wasn't, not in any formal capacity.
Mm-hmm.
So the PhD, so in Denmark, PhDs are typically 3 years when you already have a master's. But I got into a separate kind of program where you sort of finish the master's while starting the PhD, and they kind of overlap a bit, and it takes a little bit longer. And the project, and also you're sort of fully funded from the start, and there's sort of an expectation that you're sort of generally working on the project you get hired for, and you're considered an employee rather than just a student. So you have, 5 weeks of vacation, parental leave, sick leave, all the good stuff there. And so I was originally, the project I ended up being hired for was to work on a DSL for specifying actuarial products, because after the big financial crisis, the EU instituted new rules for calculating solvency of large portfolios, life insurance and pension. And that meant that you could no longer just figure out solvency for each policy in your portfolio one at a time, then sum the result, because you had to take the correlations of people's behavior in various simulated economic stress scenarios provided by the financial regulators into account. And those correlations meant that you had to do like portfolio-wide calculations. So we're like, well, how do we do this? Let's make a declarative specification and then try generating some nice fast CUDA code. And along the way, we're looking at this and we're like, well, what happens if somebody makes a mistake and tries to add, 100 krona from 1983 to 100 krona from 2013? Like, that's a 30-year gap, and there's been a fair bit of inflation there. You got to remember to, like, discount them so that they're sort of make sense together. And we're sort of inspired by the unit of measurement types in, like, F#, sort of based on Andy Kennedy's stuff, and thinking, like, okay, well, what we could do is we could make the type of money be time dependent. Let's do some dependent types. And like, I was, continuing my being a nerd. I'm like, I'm trying to learn Agda for fun, because as one does. And, before I started the PhD, I'd worked through a good chunk of software foundations as like an independent project. And I thought these things are super fun to work with. And I was like, all right, cool. I got to do some dependent types and see how it works out. Let's do some research. I'm like, how do I implement this? And there weren't any good resources that I could find on actually implementing a dependent type checker at the time. So I'm kind of like trying to figure it out, basically. And then, like using there's like a small implementation of some stuff in the @Tabl book, like advanced topics and types in programming languages. That's got like a dependent types chapter, but I didn't understand entirely what I was doing. And then I go to the summer school in Scotland because, PhD students go to summer schools a lot. Edwin's presenting this language Idris, and I'm like, okay, cool. This looks kind of like Agda and Kak, and I'm sitting down and using it. And I'm back in the dorm room. I'm like, this REPL has no tab completion, and it's really frustrating. And so in my dorm room, I'm going to give it tab completion. And so I did. And because Idris was pretty small back then. It was written in Haskell. I knew Haskell decently well. And I'm like, okay, cool. And so I sent the pull request against Rachel. That was kind of fun. Let's do another one. and then sort of iterate that a few times. I'm like, okay, cool. How do we take Idris and like split and make it so I can reuse its implementation for my DSL, so I don't have to write dependent type checkers for every fun DSL I want to implement? And essentially, Idris ate my project. I started getting from like, let's do code generation from a declarative spec to let's put dependent types in a declarative spec to here's the dependently type programming language. Let's see if I can reuse parts of it to like, I'm going to hack on this thing. It's awesome. And then all of my collaboration with Edwin was remote, and he was really wonderful all the time, and like, treated me as a peer and took really good care of me as a contributor, even though he had no formal responsibility to do so. I wasn't his student. He wasn't my advisor. I wasn't working on any of his funded projects or anything. But he did take a lot of time to mentor me and help me learn how to do things, which was wonderful. But yeah, so that was like my advisor was Peter Sestoff, who was also super awesome.
Most of your project was working on Idris, and so did your advisor could give you good advice? How was his role in your project?
Yeah, so I mean, in the start when we were doing the GPU cogen stuff, he'd put a lot of time into studying that, and so he could give a lot of like hands-on things.
Mm-hmm.
Later on, I mean, there's an expectation that PhD students become more independent over time.
For sure.
And so he thought like, okay, you're doing something cool, like. He's got a really deep background in programming languages generally. It turns out that implementations of dependent types look a little bit like partial evaluators, and he did a lot of work on partial evaluation, and so he could kind of point to some things from that field that could be relevant. He's a very good written communicator and was really able to help me learn how to write clearly and efficiently and effectively, all those things. Like he was very good at helping me learn how to give good talks, and like it's not that it's not that he didn't understand dependent types at all, but it wasn't his main area, but that was okay.
Nice. I like that because, sometimes we think that we have to have this perfect match with our advisor and he has to be this way or hands-on or be giving very good. But the kind of support and the kind of things that we get out of an advisor in that relationship, it varies depending on the people and the relationship. So that sounds like a lot of very good stuff, like learning how to write, learning how to present, and all of those are, I think, are probably the most important part of the PhD. Like being part of the academic community, you have to be able to present your work in a particular way using the particular parlance of the peers.
Another thing that was really important is that Peter was always really good at, he always put a lot of emphasis on communication to the general public of programmers as well as to other academics.
That's very nice.
Yeah, so he wrote sort of precise books about popular programming languages like C# and Java. He made, textbooks, instructional materials, those kind of things. And so he was also very supportive of me, going out to a lot of like user groups and industry conferences and giving talks there, even though it wasn't something that's going to sort of formally help you graduate. The reasoning is that the university is funded largely by tax money, and I was funded entirely by tax money, if I remember correctly. It's a little hazy, but the way I remember it is that the Hohe Technologie Fund, like High Technology Fund, I think they changed their name, but I forget what the new name is. They gave themselves like an English name. My understanding is that the company we were working with funded their work on the collaboration, and that the academic side was funded by this public body, if I remember correctly. But, like if the public is funding us, then we should be benefiting the public. And a great way to benefit the public is to not only produce new knowledge, which is superly beneficial, but also to help shorten the gap between the new knowledge and the people who can use it to get stuff done.
Right.
But you're no longer beholden to the taxpayer, and yet here you are on a podcast. I think that there's probably some deeper, maybe it coming from like a non-CS background or something like that you learn computer science through those types of communicators like yourself, that maybe that drives you.
I don't think that my route to learning computer science is so different from so many other people's. Mm-hmm. I learned BASIC from a book in my school library when I was like 8. I mean, it's not that it was not that I was like, reading lots of Aristotle and being like, okay, cool, now I need to learn some Python. Like people do that and that's cool, but my path was very much the old stereotype of the kid who was programming for fun on the PCXT to the basic prompt that you got without a disk in the drive. Mm-hmm. No, I think that this was just a case of a very good match between me and my advisor. We got along really well, and we still do. Like I see him from time to time.
As somebody who spends like a lot of time, communicating out with the public, what would you say? Do you have any like tips, I guess, or anything that you've learned over the years for like I don't know, having a better impact or being clearer? What do you?
My answer to that question is going to be no, but I will try to say no in a slightly more in-depth manner. So I don't feel like I have any tips because I don't feel that I ever explicitly sat down and practiced the skill of communicating to non-specialists. It's something that I learned implicitly rather than explicitly, and I haven't put in the work to be able to formulate exactly how it works. So it's hard for me to say, like, here's a generally applicable tip. But the thing I typically try to do is whatever it is I'm producing, I try to get a good mental model of an intended audience and then essentially run a simulation of them in my brain when I'm reviewing things. So you got to revise things a lot. You know, you can't just write something and send it out. Like you can, but it'll be a lot better if you write it and then put it aside for a couple of days and then, you know, get it in some other format than the one you wrote it in. You know, so like if you wrote it in a text editor, like read some rendered thing or, you know, use a print style sheet if it's a web thing instead of a screen style sheet. Whatever it is that like makes it look different, and then like sit down and think critically, like where are the missing steps on this staircase and put them there. You know, so think like, oh, like, you know, maybe, you know, if I'm writing something for Popple, I might even there say gamma's a context, but I'm not going to say that a context is a thing that tells you the available assumptions or the thing that gives you the type of the free variables or whatever. But if I'm writing, you know, if I'm trying to communicate with someone with something other than like the Popple reviewers. I say this as someone who's never gotten a paper into Popple, so don't take this as Popple advice. But you know, then I try to think like, okay, like, you know, are 1 out of 10 readers not going to know what this gamma thing is? Write it down. Just say it. Like, use a sentence. It's not going to hurt anything. People can skip it. And then also that's valuable for people who are maybe used to a different notational tradition or whatever. You know, like when I was first learning about session types, they used mu as the syntax for recursive types, and I couldn't make heads or tails of it because they didn't say that in the paper, because they just like assumed like, oh yeah, mu is how we write down recursive types, but that just happened to be like my first entry into the literature, and it just really threw me off for quite a while. And try to think about people who really just know very little and try not to have missing stairs is, I think, important, and try to build things up in a sort of step-by-step logical way. And then as the other question you asked was how to have impact. That's also a thing I'm not so much sure about. I think do a lot of stuff and something will stick is one. And the other is that actually there's very, very few written sources that describe lots of important things. And so the chance that you don't have any competition, at least in our area of the world, is actually quite high. So it's not like it's that hard to make a thing. Like if you make a good thing, then probably it'll have readers and be valuable to some people.
Do you have a favorite like type of like a medium for presenting? Because you've done presentations, podcasts, a book.
Chill books.
Yeah.
No, I don't.
Yeah. Each like has its own function. One is kind of for easy listening and others for more intense study. I mean, writing is awful. I'd rather podcast any day rather than write.
Okay. I really enjoy writing, so.
Do you like writing?
Yeah.
Oh, you like writing?
Yeah. Or I wouldn't do it.
Okay. Well, that's a secret. He just likes writing. Well,
like, do stuff that you like is always a good advice when it's possible. I mean, for most people, it's not possible most of the time. But you know, if you're like, oh, I want to help people learn things, then, and there's like one format where you feel happy, like podcasting or blogging or, you know, talks, like, do the thing you like, because like it's not like anyone's going to pay you for this, right? So it's really, really hard to get like paid any sort of reasonable hourly wage for most kinds of this kind of thing. Like, you know, so if you, at one point I calculated a probable hourly wage for working on the little typer, and it was like $1 an hour. Like it's gone up a little bit because like royalties keep coming in on the like long tail, but there's not that much royalties. I mean, you know, dependent types books is like a small market, and I could have made a lot more money doing other things than that. But that's okay. Like, you know, I really enjoyed it, so it felt fine.
Would you say that's what motivates you to tackle a new project, is whether you're going to enjoy it, whether you like it? What is your motivation in that sense?
This depends a lot on the stage of life that I'm in. I'd say once when I was younger, I'd be like, yeah, do the fun thing. Like, I'm not good at doing boring things. And so but I am good at doing fun things. So I just do that. As my circumstances of life changed, I have to think a little more and be like, can this pay our mortgage? Like, I don't have much time outside of work hours to do random technical stuff. I think it's fun to do random technical stuff, but like I said earlier, I've got a 4-year-old and I want to know her while she's small, and she's not going to be small for very long. So I've got a dog and like a whole life that isn't technical things. And so, pretty much if I'm going to do a technical thing these days, it's got to be something I can do in work hours or something that takes very little time. Like I can sit down and do a podcast with you. That's fine. That's a couple hours. But like if I'm going to like sit down and, I want to write like a tutorial on something or other, I'm going to spend like 16 hours polishing a piece of text. Like it's just not going to happen at this stage. Like it probably will start happening again in 10 years when I've got a teenager who doesn't want to see me very much, but I hope she'll want to see me. But I know people with teenagers, and typically they don't. But yeah, so these days it's very much like try to find a good match between things where what I'm making is valuable enough to somebody else that they want to pay me to do it, and where like I enjoy it enough that I'll do a good job and be efficient at it. And I've got a good match right now. So
you were at the Lean Foundation, Lean Trail.
Yeah.
How did that happen for you to write the book about Lean? You came up to them like, "Hey, you guys, would be nice if you guys had a book. I'm willing to write. Will you pay me?" How did that work? How'd that go?
All the way around. So my involvement with Lean happened, I believe it started at Popple in Paris. So I think that would have been 2016 or 2017. I guess it would have been 17. Yeah, Popple 17. So at this time, I just finished this like fancy Idris metaprogramming thing where like compiler guts were made available in an API with like a monad. And so you could, script the compiler to build stuff for you. And it was really fun. And, someone said like, "Oh, you should go talk to that guy Leo over there because they're doing really similar stuff in Lean."
Right, yeah.
So that's why I found it like, okay, cool. So like actually, unbeknownst to one another, we'd been doing very similar stuff.
Mm-hmm.
So like, there's like, if you look like, I've got, like, there's 2 ICFP papers sort of one year after the other, whereas like, like I do a fun thing in Idris and they do a fun thing in Lean 3, and like, they're like, and we're like that one, but like, here's all the ways that it's better. It's like, yes, progress. But they didn't start when they saw the thing, right? Like we started independently of one another.
Mm-hmm, right.
And arrived at a sort of reasonably similar design, simply because I think that suggests it's a good one, I guess.
Yeah.
In various ways. I think the Lean 4 one is even better than the Lean 3 one, But yeah, so I kind of knew him, and like we'd had a good conversation. And then, I was a postdoc at Indiana University at the time. And so Leo, had Microsoft Research fly me out to Redmond for a week to do some work together. And so we did that. And, we had a lot of back and forth about like meta programming. And I tried to like brain dump a lot of cool racket technology over to him because I'm like, this stuff is really awesome. And the typed functional programming people need to pay attention and learn from it, which they did, if you look at Lean 4. And it was just a great time. And, I gave him a copy of the little typer and he enjoyed it. And then a while later, after we'd moved back to Copenhagen again, I get an email from Leo like, "Hey, we might have a project." So I get a call, and they, at the time, Microsoft Research wanted there to be better materials for programmers to learn Lean because there were materials for aimed at mathematicians, but not aimed at programmers. And the things that were aimed at programmers were all like, okay, first learn Haskell, then come back to us. And they wanted a shorter path. Like, I think that's actually pretty good advice if you have a lot of time, but if you have less time, maybe not so much. And so they said, like, we want you to write a book that will introduce people who know sort of popular mainstream imperative programming languages to writing programs in Lean. Like, not a book about verification at all. Like, there have to be some proofs because of the nature of the language, but it's a book about like, how would you write cat in Lean? Or like, how do you write LS in Lean? Much more so than how do you prove that your balanced tree implementation has the right algorithmic complexity? And then, I went off and worked on this for a while. And this is actually a great way to write something because they paid me hourly for this book.
Nice.
It was great. And they gave it away for free, which I think is a wonderful model because, it's much better to have your stuff get read than to like, I'd much rather people like don't pay for the little typer, go get it at a library and read it than like not read it because they can't afford it. I'm not going to encourage anybody to commit copyright infringement because my publisher also put a lot of work into that, and I don't want them to miss out on their things. Like, publishers are not useless, but like, the royalty check for me is not motivating at this point, or really ever. Like, the point was to get it out there, and working with a publisher was a good way to do that. But in this case, they're like, "Oh, we're going to pay you hourly." I'm like, and put it out for free. It's like, this is perfect under an open license, even so people can build their own things on top of it if they want. And so yeah, I sort of sat down. I don't remember exactly how long I worked on it, quite a long time. And essentially every Saturday after I finished work, I finished work Friday and then get up Saturday morning and go to work on the book all day.
Wow.
And that was a lot of fun. And that's how that book came about.
When did you start writing? Which year was that? Was it 2020, 2021? Or even more?
If you go look at the book's webpage, there's a release history. I don't have it in my head. It's all swapped out or like put on tape back up at this point. Like, yeah. I'm not good at maintaining calendars in my mind. I just look in the computer if I want to know that kind of thing.
That is actually very nice. But how would you compare Lean and Idris? What are the differences? What are the similarities? What would be the use cases for each one of them?
So I want to start off with a big disclaimer, which is that I haven't really kept up on Idris for the last few years. Mm-hmm. And I will say what my best understanding of the status of things is, but probably I'm going to be unaware of some really cool and awesome thing they've done. And so first off, apologies in advance to anybody listening who gets misled by me. And also, please follow up if I say something that seems implausible, and happy to get corrections and that kind of thing. So Idris is first and foremost a programming language with dependent types. And Lean is first and foremost an interactive theorem prover. And this is reflected in a lot of aspects of the trade-offs of the system. So, for example, Lean has a very conservative logical foundation. This is the Lean type theory. Like, it's changed a couple of times, but it changes very rarely. Like, the changes were like, we're gonna, get rid of mutually inductive types, and then put them back in, kind of stuff. Not like, but like Idris is, Edwin's been experimenting with quantitative type theory where you can, annotate binders saying how many times a thing can be used, like, 0, 1, or many, where 1 gets you a linear, like it gets you linear typing, and like the many gets you like normal intuitionistic stuff, and 0 gets you like a guarantee the stuff is erased at runtime. This grew out of a lot of challenges that were in the original version of Idris with trying to say this, we're going to do some dependently typed programming, but then we end up with like a lot of junk at runtime that makes the program slow that we don't really need. So if you don't do any tricks and you compile the standard example that everybody uses, and I'm going to use it because it's a good example, which is the length index list. Look at the type that you get in your core language for the cons operator for that. It's going to take a natural number, and then it's going to take an element, and then it's going to take another list, and that list itself has a natural number sitting in it, right? These natural numbers, because we're compiling things without any tricks, are themselves linked lists, essentially, right? You've got successor of successor.
Right, yeah.
So if you do things the totally silly way, then you end up with a quadratic overhead for space on that data type, which most people don't want. Ideally, you actually want, at least in many cases, you want the length to not be present in the program at all, right? The point of the length there is so you know that your accesses are bounds checked at compile time. It's not really there because you want to keep it. And, in Idris 1, there was this system Edwin's student Matush did for doing a global whole program analysis and saying like which things contribute to the answer produced by main, and if they don't contribute, get rid of them. And so as long as you never projected that nat out of the vec or out of the cons, then it would be erased. And that was cool, right? That was an improvement over the stuff Edwin did in Epigram, where they used like special eliminators to do like the whole forcing and detagging thing. But it had some like real modularity problems, right? Like somebody like, one bit of code that like accesses one field in a data structure might make the whole thing super duper slow, and it's really hard to track down. And then you start to think like, okay, well, maybe we should like annotate our intent that this thing gets erased. But then like, okay, well, is that going to be part of the theory, or is it going to be like a separate pass, and da-da-da-da-da? And actually, if you follow that line of reasoning, then you can see why when quantitative type theory came out, like Connor McBride and Bob Atke did their work there, that seemed very appealing, right? Because essentially with quantitative type theory, what you're doing is you're writing down this thing doesn't exist at runtime in a way that's part of the theory. So all the logic should work, and you should be able to use it as, maybe not as an internalized reasoning principle, but at least to reason about your programs together with your types, which is very nice. And also, on the side, Edwin cares a lot about practical programming, so we've been experimenting with linear types to be able to mutate things that instead of allocating new ones. And so the fact is that we're linear types, that's a lot like uniqueness types, which Idris 1 had as a sort of experimental extension that But like, none of this has like the full meta theory that you'd want. There's Idris 1 certainly had injective type constructors, which is inconsistent.
Yeah, I was just looking at that for my thesis right now.
Yeah.
In the presence of excluded middle.
Okay, I thought that somebody else had a proof of false that came. Like, so I remember that originally there was that post like on the Agda mailing list years ago that was like showing that type constructor injectivity is anti-classical, which is, excluded middle.
Right, exactly.
But I thought that somebody else actually just could derive false from it as well.
Oh, okay, maybe.
With like a diagonalization thing. But I could be wrong.
Okay, maybe I didn't check that far.
I'm not super awesome at meta theory, so I could definitely be remembering that wrong. But like, it's fine for writing a program, right?
Yeah.
So,
yeah.
Idris has really been getting much more and more like towards being a language that works well for programming.
Mm-hmm.
And I think that's a great trajectory. And, Edwin's got like with this type-driven development book, he's got this whole way of thinking about programming where the system helps you write the program and like refine the type together with the program. And there's like a whole way of thinking associated with it. And that's really not the way Lean is put together. I'm not going to be able to give you like specific technical stuff that says do it or not. It's more, let me digress a little bit.
Yeah.
There's this great essay by Kent Pittman in the 90s that grew out of the Lisp standardization efforts where they're sort of trying to sit down and make Lisp interoperable across all these different implementations. And so, he was a part of the process and he wrote this essay. I forget the entire title, but it has the subtitle, Lambda, the Ultimate Political Party. I talk about this a lot because I think it's a really important insight. And so, I'm not always good at shutting up and not repeating myself.
No. Please keep going. I just remembered of this paper. I'm like, this is a pretty cool story. Yeah. It's a pretty cool paper.
And like a lot of the stuff is sort of like 90s concerns that aren't so relevant today. But there's a really important thought experiment that's used to bolster one of the arguments, which is the part of this essay that was most influential for me. And so he proposes that, as a thought experiment, that we take the C programming language and the people who are using C every day keep using it. And then also you give it to everybody who's using Lisp and say, like, this is your programming language, have at it. And then like, don't let them talk to each other. And then like 10 years later, we come back. I don't know if the number was 10, but some time goes by, we come back and we're like, okay, what do these programming languages look like? And the C user's version of C is going to look like a lot like C, right? Like maybe it's got a Boolean type now, like it's C99. Maybe it's got some like, stuff around the edges. But like the Lisp programmer's version of it has probably got garbage collection at this point. It's probably got macros. There's probably some more parentheses sneaking in somewhere. It likely won't run on cheap hardware anymore. That used to be true about Lisp, not so much these days. But, and the conclusion is that a programming language is not just a thing, like a formal specification for a thing. It's also an artifact that is collectively maintained by a community of practice. I don't think he doesn't use this terminology, but it's the way I think about it. And so the values of that community are shaped by the technical artifact and in turn shape it. And these two things can't really be separated from each other.
Mm-hmm.
Right? So as programming languages researchers, we like to sit down and be like, okay, well, here's my type system, here's my operational semantics, cool, my language is done. Maybe I implement it too. Right? But now I've said what I need to say about it once I've specified the static and dynamic semantics and like the syntax. But programming languages in which people write programs, and not like example programs, but in programs that they want to use to solve their problems, like I've certainly experienced that learning a programming language changes the way I think about programming.
Oh, yeah.
This happened with Haskell. This happened with Lisp. This happened with Racket. Again, this happened with Smalltalk. This happened with like working through software foundations, happened learning Idris, Objective-C. Like C also changed the way I think about programming because like, oh, pointers, I get it now. And the fact that, and like people say this all the time, right? Like, oh, this language changed the way I think about programming. Cool. But that also means that the people who are using a programming language will tend to start thinking in some similar ways, assuming that it affects them in similar directions, right? Like people who like get into Rust, like start thinking about ownership and in a way that they didn't before because the language makes them do it. And they're going to take that experience with them. But it also means that the Rust community will gravitate towards ways of working that can leverage that, which will then mean they'll put pressure on the Rust developers to make it better for those kinds of programs, and that these two things kind of mutually reinforce each other over time. So the way I think about these various interactive theorem proofs, these various implementations of dependent types, however you want to think about it, is really kind of that way. And the community surrounding Idris is very much the traditional functional programming community. Not the people who want to do prove all the things everywhere correct. It's like those people are using different systems typically. Like, but the people who'd be like, oh, here's my cool fancy typed Haskell library. A lot of those people fit in really well in Idris, and Idris works really well for a lot of those kind of things. And Lean is very much influenced by the fact that a bunch of professional mathematicians started using it, and it started reflecting their values. Like professional mathematicians who aren't computer scientists and who aren't type theory people. And so that means that a lot of the things you see there are reflecting that use case. And, like I think last I looked, MathLib was like 1.4 million lines of code now. And
it's huge. Yeah.
It's so big. It's so cool.
It is very exciting.
And, one of the big priorities of Lean development is to like keep supporting them because they do such cool stuff. And that is, that definitely like puts pressure on the way the language evolves. And that's a good thing, right? Because it means that it gets better for people who like to work the way they like to work. And I've heard some interesting things. Like, I'm not at all one of these methods. But I talk to them, they're like, yeah, like we don't define inductive data types. I'm like, what? They're like, oh yeah, we define structure types all the time and like package some stuff up. But like, it's very rare, apparently. This is hearsay. But like, it's very rare, apparently, that they write proofs by induction. Right? And like in programming language, we're like, proof by induction on the typing derivation.
That's it.
Boom.
Everything you do, yeah.
Yeah. And they're like, like sometimes we do it with a natural number, but like that's basically all. And like that's interesting. And also, it's not that mathematicians aren't programmers, right? Like they also need to be able to like develop tactics and that kind of thing. And I think part of the extensibility of Lean is to try to make it easier for them to write the tactics they need to use to get their work done.
How easy is it, do you consider? Do you think it's that easy? It's better than, say, Coq?
I don't know. I'm not familiar enough with like the state of the art over in that land. Like
they use a lot of metaprogramming and quotation, and you had a blog post about quotation, for example.
Yeah. So that was a different kind of quotation. But yeah, quotation is many things.
Sorry about that.
Yeah, I mean, I don't want to make comparisons to things that I know nothing about. And like my Coq experience is limited enough and old enough at this point that I'd probably just be talking nonsense if I tried to say what's easier than the other. Mm-hmm. They're very different, right? So the Lean approach is one where you really have a fairly low-level compiler internal API, which is like a big stack of monad transformers that have access to various like reader and state effects and can throw exceptions. And then you could say like, okay, like I got this meta variable, I'm going to unify it with this thing, or I'm going to unify these terms and like assign the meta variables or like roll back the state. And that is not easy to learn for a lot of people. If you've worked on the internals of a type checker, probably it's not so hard, but most other people haven't. So I think that this is an area where we could try to make it easier, but also it's hard to try to make a high-level system that still will go fast for really big problems. Mm-hmm. And so I think that a lot of the really powerful automation in Coq is, and I'm calling it Coq because I looked at their website and it still says Coq. I know they're renaming, but I don't really know which name to use. So I'm sorry, but I'll use what the website says for now.
Yeah.
And I know that there's a lot of automation that's written in OCaml and plugged in. And I think that a lot of the Lean stuff is essentially at that level of abstraction. It's just you write it in Lean in the same file you're working in because of the metaprogramming facilities. Mm-hmm. It'd be nice if it was easier. And you can write simple tactics as macros that expand to other tactics. That's very easy to do.
Okay, that's interesting.
But if you want to write like the really crunchy stuff, then you really have to put on your wizard hat and start casting some spells. Unfortunately, I'd like to. There's a nice community-written book that takes you a good chunk of the way there. But I think that I hope that later this year I'll have time to sit down and make more resources that cover the parts that doesn't, and kind of collect and unify the whole thing.
Oh, yeah. Every time that I start talking about Lean, I want to sit down and learn more. That's still on my back burner because I know just the bare minimum. I started your book and then I stopped doing it.
Yeah.
I remember I was really excited when I opened VS Code and everything started working right out of the box, and the tooling is really cool. So I don't know. Lean is a very exciting project. And it's very exciting that Terence Tao is kind of backing that up now, right? It's like, wow, things are blowing up.
Yeah, I was really happy to see him using it and making progress and enjoying it.
Yeah.
And we've been lucky enough that we managed to, I guess I should say, Leo and Sebastian, with help from Convergent Research, managed to get some funding together that we can actually have the resources to really try to polish this thing and make it accessible to a lot more people than it otherwise could be.
You're talking about the metaprogramming facility or Lean in general?
No, this is Lean as a whole. I mean, we've got, I think at this point, there's more full-time people working on Lean than on GHC.
Oh, wow. That's pretty cool. Pretty cool stuff.
I think that's, just because we managed to get this, or I should say, Leo and Sebastian managed to get this nonprofit put together. And it's a 5-year program, right? So we've got to put together a way to make it sustainable, which is our long-term goal for our nonprofit, is to transition into something that can be sustainable on a long-term basis.
So you guys they could get a 5-year grant from where? What is the idea there? What is going on?
So I'm a little out of my league here because I haven't done the financial side. So I'll give you my best understanding. So there's this philanthropic project from Eric Schmidt, founded by Eric Schmidt, called Convergent Research. And what they do is they find projects that are, where there's a lot of research put in, where it's, mostly working, and, there's, perhaps the research work is almost done, like there aren't a whole lot more papers to put out, but nonetheless, it hasn't kind of crossed over and become used by society as a whole.
Mm-hmm.
But it could bring a lot of value if it was. And then they work with the researchers to get funding from large foundations to create, to make a transition happen. And then they employ a team of people at normal market rates for 5 years, solve all of the problems that won't get you a paper necessarily, but will get the thing used. And mostly they haven't done computer science in the past. I think we may be their first computer science project, but they've been great. Like, I worked with them for going through the hiring process initially and all that. And they've been extremely helpful and competent people. And you can go to the Lean FRO webpage and see a list of big donors there. I don't want to list them off by memory because I might forget one. But
you're fine.
Yeah, and so our goal is to find a way to make it sustainable, and that could take a lot of shapes. If 5 big companies start using Lean and they employ people to work on it, that's success. If we have a foundation like Rust does that users could contribute to and that funds it, that's success. If we end up starting a company and selling it, that's success. What matters is that it's out there creating value in society and that it's financially sustainable in some way or another.
Yeah, that is awesome. That is very exciting.
It's wonderful.
Hope you guys the absolute best. But you mentioned that they hired you initially to write the book, but you're still hired
sorry.
with them? Is the book finished?
Yeah, so Microsoft Research paid me part-time to write the book back when Leo worked at Microsoft Research. He doesn't work there anymore.
Mm-hmm.
And then, the book was finished and then that project ended. And then Leo kind of said, keep this a little quiet because it's not a sure thing yet, but it looks like we'll have this funding for this FRO. Do you know anybody? Yeah, I'll think about that. I'll get back to you. And, I was talking to my wife. I was like, yeah, whoever gets this job is lucky. She's like, why didn't you suggest yourself? And I'm like, I can't suggest myself. And she's like, yes, you can. And so I wrote to Leo, what about me? What are my big interests, right? Dependent types, functional programming, hygienic macros, compile time metaprogramming, documentation communication. I'm doing all of those things, right? This fits me like a glove. And, and it was really tough, right? Because I also felt like I was doing useful stuff at Haskell Foundation. And, but I thought about it, this is one of those extremely rare opportunities, which the Haskell Foundation also was. I don't know. And I really had to think hard, but I decided okay, this is the perfect technical fit and I'm going to go for it. And that's how it came about. So there was actually a gap.
Okay, gotcha.
Between finishing the book and then starting the Lean job.
Because then you were how can I say, finishing your work with the Haskell Foundation and then...
Yeah, I tried to give the board as long of a notice as I could so they could have a good transition plan and also so I could help out with the recruitment process for a successor as much as possible and that kind of thing.
There are 2 ways that we could go on right now, and I want to go through both. The first one is talk a little more, start talking about your work on Haskell Foundation and how did that happen? How did you get involved with all of that? But before, let's just finish these things of the Lean Flow. Could you tell us a little more about what you're working on right now?
Yeah, so my main project is a documentation system called Verso. And if you're wondering about the name, I was trying to find a word that sounded like documents that didn't sound boring. And that was really, really hard. And also didn't sound pretentious.
Isn't the soul of the word document? You did a good job, though. Verso is very exciting.
Oh, thanks. Yeah, but what it is that a piece of paper in a book, if the paper is kind of on the right-hand side, that's called the recto side. And then you flip it over, and that's the verso side of a paper.
Oh, in Portuguese, we have a similar word. Yeah.
Cool. Yeah, also if you really care a lot about like the way your thesis is typeset in LaTeX, then you can get in and say like, this has to start on a recto page. And that occurs in like a keyword somewhere, which is where I learned the term.
Oh, but, wow. Okay. I'll keep an eye on that because I'm writing the thesis, so that's important.
Yeah, so typically the margin on the left will be a little bigger for the recto page and on the right for verso page.
Oh, yeah, right, yeah.
Because that's what the binding of the book is going to be, and so it's easier to so you don't like your text doesn't look cut off, but because of the little minor fold in the paper.
Yeah.
And also you want chapters to start on a recto page if you're really detail oriented, which Dan Friedman absolutely is. And writing the little typer with him taught me an awful lot about how to lay out paper. But you know, he really cared a lot about those things, and I cared, but I didn't know, and so I learned. But yeah. So and also like, you know, the recto side was the right side to write on, like because papyrus you can only run on one side of papyrus. And so the recto was the correct side, and the reverse verso side, that was the less one. I thought like the sort of connotation of being a bit underhanded was kind of fun.
Yeah.
Anyway, so that's where that name is from.
And you didn't want it to sound too much like rectum.
I hadn't thought about that, and now you've cursed me. Thank you. Yeah, so verso is heavily inspired by Scribble, which is the standard Racket documentation tool, and also to an extent by Sphinx, which I've used a fair bit for other documentation projects like Idris and some work I did at Galois, and a little bit by LaTeX and some other things. But those are the two biggest sources of inspiration. And I had a lot of struggle working on both the little typer and the functional programming in Lean, because I get everything wrong if a computer isn't checking my work. But arranging for the computer to check my work is pretty labor intensive and painful and involves a lot of regular expressions. You know, so and like if you look at the errata for the little typer, you'll see there's a fair number, and all of those are things where the computer wasn't checking, like things the computer didn't check. And I wish there weren't any, because you know I wish we'd put more effort into the automatic checking of the examples in the book. But you know, having learned that lesson, I put even more effort into it for functional programming in Lean. But it was pretty painful, and I ended up with an ad hoc system involving like a pile of Lean, a pile of Python, and a pile of Rust that, you know, worked for this purpose. But if I want to do another book, I'd probably have to do it again. And if I know the book, I'd do it again. At the same time, people write documentation for software in a lot of forms. Like we write about programs in a lot of ways. You know, we might write a research paper where we want to have our code samples generate our figures so that they don't get out of sync or we don't have a typo. You know, the valuing this heavily really came from learning PLT Redux and watching Robbie Findler's talk, which I recommend everybody do because it's a fun talk. Controversial because he pointed out a bunch of typos in papers, but you know, I think techniques for avoiding typos in papers are good. And I think that the spirit in which it was offered was one of, this is a systematic problem, not dear authors, you're bad. But I could see how somebody might take it that way. Yeah. So I'm thinking like, okay, you know, I want to write a research paper which interacts nicely with the compiler, and I want it to be easy to build this. I want to write a book about something. I want that to work well. You know, I want to write documentation for how do I use my library. And I want that documentation to be something that I sit down and structure and think about rather than just, you know, grab the doc strings out and put them in some structure dictated by the structure of the code, like you get with Java doc and its and its descendants like Haddock and KDoc for Kotlin and Scala doc and all these things, you know. Having done a fair bit of Racket, I've used Scribble, and Scribble does a lot of this, right? Like you can use Scribble to write a research paper, and it's nicely extensible. Like so the way Scribble works is it's an alternative concrete syntax for Racket that's more ergonomic to write documents in, along with a library for writing various kinds of document, like software manual or research paper or whatever. And it's really nice because writing extending the language in which he writes documents is just defining a function, which we do all the time, right? So if you want to support, let's say you're writing something about state machines and you want to have a little concise way to specify a state machine and then have it, you know, render a figure and in various places in your document and maybe highlight certain subfigures of it that you're going to point at, then you can just do that. Just write a program and it's not horrible. You could do this with ticks, but it would be pretty painful because of error messages and the evaluation model. But writing programs that take values rather than string macros is actually much easier and much nicer, and you can test it and all these things. And you know, I really missed having that when I've used other tools. Sphinx gets you a lot of the way there too, because you can hook up, you know, like restructured text has a dedicated syntax for talking about extensions to your document format. And then in Sphinx, you can wire up Python code that runs in response to these extra things. So you can actually do a lot of this in Sphinx as well. But the nice thing about Racket, about the way Scribble works in Racket, is that all of your normal Racket tooling just works for your Scribble documents. Like go to definition, rename refactors, all those things work for your document extensions as well as your normal programs, which is not the case for Sphinx. So you'd have to build a whole separate set of tools for restructured text to do these things. And then, the interaction between the source document and the implementation of the extensions is stringly typed, I guess you could say. And so like the rename refactor is only going to cover one of those sides, and then you'll get an error message you have to fix. And it's not the end of the world, but having integrated tools is better than not having them. And so I thought, all right, so they want me to do a bunch of documentation for Lean. That's cool, but I want to make the tool that makes it easy to do the kind of documentation that I want to do, and then use that tool to write all the docs. And that's what Verso is.
Okay.
We're using it today for our blog. So if you go look at our blog post, you can see that having your documentation language integrate with your compiler metaprogramming API means that you can, put fancy highlighting for code examples without having to work very hard at it, or have a complicated build process for your blog post, which is nice.
Is Verso written in Lean?
Yeah.
Cool.
Verso is a Lean library.
Okay.
But the thought process is really, as we saw with Scribble, like sometimes you want to write a manual, sometimes you want to write a research paper, sometimes you want to write a book of recipes and you just like the tooling you're using for your day job, so you might as well use it for your cookbook too. Sometimes you want to write a blog, you maybe want to write like a one-off web page with a tutorial in it and not do like a whole blog using the tool, all these different things. No one tool is going to serve all of those use cases well.
Yeah.
Right, like something that works well for writing a book is going to give you features like numbered figures and an index and a glossary. And something that works well for a blog post is going to give you links to other web pages. We shouldn't expect that one thing will work great for all of those. But on the other hand, they do share a lot of concerns. Like in all of them, you want to be able to like do some boldface text. In all of them, you want to be able to do a heading. In all of them, except maybe the cookbook, it's plausible that you want your compiler metaprogramming API to be available so that you can do something fancy there. Maybe you've got some nice way of doing diagrams from some DSL, like ticks kind of stuff. And I've used ticks a lot. Right, like this is an aside, but like the inference rules in the back of the little typer, like we actually had to like lay them out using ticks because we couldn't get it to work with like combinations of array environments. That was an intense couple of days.
So much work, man. Right, that's so much work.
It was an intense couple of days. But yeah, okay, but returning to the topic. So we want to be able to like share features between these different tools. We don't just want to have one tool. And what do we do in programming if we have like a bunch of related tasks that aren't the same but share some concerns? We make a library. So Verso is actually at its core a library for building documentation tools that are convenient to work with. And it gives you some bits and pieces you can use, and then you can contribute your own just by depending on it and writing a library. Like you don't have to upstream everything you want to use, because I don't want to have to review a million pull requests for use cases that are important but niche. I think things that everyone wants to do, I want in this repo. Things that a few people want to do should just be their own repo with their own library, and you just depend on it the usual way. And so what Verso provides is, first off, a concrete syntax, which is highly Markdown compatible, but not actually Markdown. It's highly Markdown compatible because Markdown is extremely popular and people just assume things will work the way Markdown does today.
Yeah.
Which didn't used to be true. Like when restructured text came out, like Markdown didn't exist yet. And, tech was a thing. Like when Scribble came out, it looks a bit like tech, but with @ signs instead of backslashes for its concrete syntax. But the trend these days is a sort of Markdown-y looking thing. And that's what people are going to expect. And so, and I think that for most people, like the most important thing about syntax is that it's familiar rather than that it's like good in some objective or technical sense.
Yeah, right.
And like there can be technical blockers that make syntax bad, but like in the absence of those, all of them are going to be fine. So just do the thing people already know, because then you don't have to explain it. But the reason it's not exactly Markdown is because of certain technical priorities that are important to the project that Markdown would have made impossible. One of them is I want to have good support in the IDE, and the fact that Markdown specifies that every string is a valid document, just maybe not the one you thought you were writing, means that you can't like give red squigglies if somebody forgets a closing delimiter. Instead, you just have a bunch of fallback rules that are precisely specified in the common mark specification, but nonetheless are fairly intricate. And I think the user's mental model should be like, if I write something questionable, then the machine will complain at me until I make it no longer questionable, rather than I have to proofread my document carefully to see if I forgot like a closing inline code block backtick, and thus the opening backtick is just a literal backtick in the middle of my paragraph. And if you're reading a 200-page book, like those are hard to spot.
Yeah.
And also, the other advantage of having syntax errors is that you can add things to the language without breaking existing programs by using syntax that doesn't already exist. I don't plan to add a lot of things to the Verso markup, but I might add a feature at some point. And then I think people who, if you add a feature to Markdown and somebody was already using that syntax for something else, that's a problem because things will silently change their meaning. Right? Because if you want to extend Markdown, you do it typically by like a string preprocessor that, finds this regular expression and replaces it with this other thing. Or you parse it fully to an AST. But there's not really like a hook to say, like there is in restructured text to say, here is my ingredients list for my recipe. Or in like LaTeX or whatever, where you define a new environment or a macro or something. And so in order to be able to support things like that, it was important to have syntax errors. And like we could say, okay, so we're going to be compatible with all the reasonable Markdown documents and just, give error message on the ones that people don't probably want to write. But then also, the precedence rules for the various kinds of delimiters are a bit complicated. The specification of the link syntax means that you have to write a 2-pass parser. You can't parse it in 1 pass. John McFarlane, the author of the Common Mark spec, wrote a really great little essay on this, drove the design of his potential Markdown successor, Jot, DJOT, which is what I originally wanted to use, but for various reasons it didn't exactly fit the goals of the project, so I ended up making something heavily inspired by Jot, highly compatible with Markdown, but a bit different, and it's its own special thing, which is going to be a problem for some people, unfortunately, but I think the trade-off was worth it. We'll see. I do plan to make a Markdown to Verso syntax converter at some point.
Nice.
Oh, I was going to say, a lot of this design of document language, did you see this paper from Brown University about a core calculus for document languages? Did that influence?
Yes, after I did the...
Oh, no.
No, it's okay. Yeah, no, that's Will Crichton and somebody else.
And Shriram.
Yeah, Shriram, yeah. That was really cool. I didn't do meta theory for my document language.
I can't believe it. Unbelievable.
That's right. No, so the model I'm following here is one where this syntax is like a thin wrapper around normal lean ASTs. So the idea is that you write your document in the Verso syntax, but what you get back almost immediately is that it just macro expands down to a normal lean data type, which is the AST of your document. So then at compile time, you're getting the syntax of the AST, and then at runtime, you can generate whatever document from that you want. And that model fits into this particular technical context. Yeah, that was a cool paper, but it didn't guide this particular design. And right, so that's one part of Verso. Another thing is that the data type of documents is parameterized over a genre, and that genre would be blog post, user's guide, whatever. And the genre gives you additional block level elements, additional inline level elements. It's essentially like a tuple of 5 types, right? You've got the type of metadata associated with sections, or like subsections or parts or chapters or whatever. And then you've got the type of state that's used during a cross-reference resolution pass, so that the system doesn't build for you, but it gives you tools to build yourself with a small amount of code. This is what is called the traverse pass inside of Scribble. In LaTeX, it's called please rerun LaTeX. Right? LaTeX is, it's making you manually compute a fixed point for your document by just up enter until it thinks it's done.
Yeah.
The reason it's doing that is because, at each pass through the document, it collects some information and saves it to a side table.
Right.
So it says, this label is located here, and, this glossary item is located here, and all that kind of stuff. And the next time you run it, it'll start resolving it, but then some things may change. And maybe when the question mark is replaced by the really long author year citation name, something gets bumped to the next page. And so you just have to keep running it until it computes a fixed point, which it almost always does within, maximum 10 iterations. I think typically it's 3. And so, but the rather than save this in side tables on disk, in Verso, the genre says like, what type do you want to save that stuff in? And then it just goes through and computes the fixed point for you. And then the other one is there's also like a reader effect associated with this where you can use to like pass information into that computation. So like for the blog post genre, it says like, this is the path to the current page that we're looking at, which it can then use for cross-reference resolution to say, oh, this label is at this URL, so you can generate a link to it somewhere else the next time through. Yeah, so those 5 things are the genre, and then the author of the tool or the genre is expected to then build whatever command line tool they need for spitting out the actual thing. And this is because those tools are actually pretty different. So the website one genre that we have, you give it a declarative specification of the URL structure of the site and like which documents are associated with which addresses, and like, this blog is with these posts associated with this subpath and so on and so forth. And then it turns that into, some HTML that you can deploy to your server. The user's guide one has a sort of an internal extensibility to the state data type. So you have to give it some information related to that. And then you just point it at the top level of your document, and then it runs off and does its thing. And, I imagine that more parts of this process will become like reusable building blocks and libraries, but I don't think there's going to be like one thing that's going to work for everyone. So that's why it's a little more customizable. And again, like most people are just going to use the tool somebody else builds, but making this easy to build the tools will mean that those few people who really like building this kind of thing will be able to do it more efficiently. That's an overview of Verso. It's like some bits and pieces you can use to make a documentation tool, and a somewhat opinionated, but not entirely sort of forced on you way that those kind of look.
I feel like you're the perfect person to be writing this kind of thing, because you've worked so much with different environments, and like different programming languages and Racket and LaTeX and all the different ways that things can go wrong. So yeah, that is very exciting. Yeah, and thanks for putting that together. I have a question actually. I thought a lot about people complain a lot about LaTeX, for example, and all the issues and all the problems, and I don't know, like it seems it's a very old piece of software as well. Yeah. I think it's from the 60s, I want to say. But
I forget. I thought it was the 70s, but I'm really not confident on that.
70s, something.
I mean, there's tech and then there's LaTeX.
Right.
And LaTeX was a few years after.
In any case, I have this feeling that it is a very, very complex piece of software that is doing a lot and is giving us a lot, and we're kind of taking a lot for granted as well. But at the same time, it's very hard to use it effectively, in the sense of we have to put a lot of work into it. There's a very sharp learning curve. I wonder if at some point we'll be able to move past LaTeX, because it's almost 50 years now that we're using this, and still the de facto software that we use for writing papers, and all of the academic process is dependent on this. What is your opinion? Do you think we will come up with something better? How do you see LaTeX? What are your views and opinions about it?
Yeah. So the meta point, the broader principle, is that I think the actual economic value of a programming language is mostly determined by things other than the technical qualities of that programming language, which makes me sad because I care a lot about the technical properties of programming languages. When I don't think they're the way they should be, it makes me sadder. But that's really my problem more so than the programming language's problem, because like almost all the stuff I use on a daily basis and care a lot about is written in programming languages that I think have deep flaws in them, and yet it all works pretty well most of the time. And I'm not gonna wish upon the world that all this stuff just disappeared. It's up to us to make the case for it. But also, when you look at like, why are things popular? Mostly they're popular because they're popular, which is just not circular reasoning, because actually popularity leads to libraries, it leads to instructional materials, it leads to books, it leads to consultancies, it leads to a great decreasing of the risk of long-term adoption, right? Because you don't want to end up with an unmaintained programming language. Mm-hmm. If I had built my business around Idris 1 and then Idris 2 comes out and like my stuff can't be ported, and then I'm just like on this end of life compiler then where like nobody's making libraries and all the new stuff is for Idris too. And like that would have not been very easy for me as a company, right? And like no matter whether the physics of the type system were absolutely perfect for a domain, which they very well might have been, I would have been better served by picking something less well suited to my particular domain, but where all that other stuff was in place. So applying this observation to LaTeX, I think, the programming model of tech is not excellent. Like string substitution and string macros are really hard to get right and even harder to make good error messages for, which we all encounter if we're using it. LaTeX does a great job raising the level of abstraction with the tools that are at hand. And I'm not going to say Knuth did it wrong because it was another time and memory was extremely expensive compared to today.
Yeah.
And programmer time was extremely cheap compared to today, and computers were slow, and the expectations we had were different, right? Like a big challenge we have with documents versus tech today is that they are not usually very good for people who use screen readers, and they're not very good for a lot of other people who aren't going to be printing out a book and looking at it, right? And a lot of people today are sort of making screen optimized PDFs, which is a problem for me because I want to read a lot of them on an e-ink screen. And they're like, we're going to use green for this thing and blue for this thing. I'm like, well, those both look gray to me. Okay. But so like there's a lot of real challenges. But on the other hand, go to CTAN. Look at all the cool stuff on CTAN. Like,
oh yeah.
So actually, you asked like, is there going to be a better competitor? I think there's been a lot of better competitors from a technical point of view.
Mm-hmm.
But what matters here is not that the technology is better. What matters is that like the whole package is better enough to make it worthwhile for us to add support for it to all of our workflows, because there will always be a transition. I think Typest is really exciting. I think they're doing a lot of cool stuff. There's a couple others I've seen that I don't remember the details of anymore because I was like, oh, this is cool. I'm like, oh. So yeah, I've written a lot of tech. It's pretty hard. It's doable. I don't know. Any competitor has their work cut out for them because of the network effects.
Right. Yep.
I'm not a business planner, so I hope nobody takes this too seriously. But I think if I was going to try to compete with tech, I would not try to make a tool that's better for writing computer science papers than tech. I would try to make a tool that's better for writing some other thing, which is really poorly served today, and then like grow a user base there, and then like bridge over into computer science after there's already a dedicated mass of users making the thing better for some other domain. Because I think the computer science people are pretty established with tech right now. But
yeah, thanks for your insight. Should we talking about transitions, should we talk a little bit about your work during, well, not necessarily the work itself, but I'm curious how you got involved to work at the Haskell Foundation.
Yeah.
How did that happen?
So the Haskell Foundation was founded. They had a two-member executive team, a CEO or an executive director, which is like what you call a CEO in a nonprofit, basically, and a CTO, Emily. So Andrew and Emily. And Emily got a job offer that she decided to take and was going to leave the HF for this other job after doing a really good job getting it going and getting it anchored in the community and getting a lot of good initiatives going. And someone got a hold of me and said like, oh, like, this is secret still, but like our CTO is looking like someone who's kind of involved in the foundation. Looks like our CTO is going to be departing. I think you'd be a good candidate. I think it'd be cool if we had, someone lined up before the announcement. And so I said, like, okay, let's have a chat. And then they introduced me to Andrew, the ED, and we were having some meetings about like, maybe I kind of want to do this. I'm not sure because, I'm a software developer at the time. I was working at a startup here in Copenhagen called Dion Digital, doing, some fun work with DSLs and I was kind of checking with them. And they decided like, actually they wanted to go without a CTO for a bit because they thought they could use the resources differently on some other things. And then the ED decided to resign. And
what is the ED? Sorry?
Yeah, I've been having Andrew was the previous ED.
What is ED?
Executive director.
Executive director.
Executive director. It's like it's what you call a CEO for a nonprofit in the US.
Ah, okay.
And when Andrew decided to resign, I'd been, I talked to a couple of board members about maybe kind of sort of being a CTO someday if they decide to have one. And they said like, okay, well, this position is open. Like, would you consider applying? I thought, maybe, and had a good long chat with my family and some of them. And then I said, okay, I'll apply. And I also talked to Andrew about it. He encouraged me to give it a go. And then I got the offer and decided to take it and then had to learn a whole lot of new things really fast.
It seems to me that that's a more people's-oriented job.
Yeah.
Instead of more programming, right?
Yeah.
Yeah, I mean, I don't know what an executive director does at all, especially at the Haskell Foundation. I don't know if you've talked about that on other contexts.
I have, but I can
summarize
what I did. So, at the time, I was basically one of two people working full-time at the HF, the other being Brian, who did like a lot of CI infrastructure work for GHC and who's later handled other infrastructure work for the community, like transferring stackage to the Haskell Foundation. And so basically doing everything, right? You got to fundraise, you got to plan events, you got to make all the decisions about the day-to-day operations. The board approves kind of the long-term strategy and the overall framework, but basically that's like a very high-level oversight role, and the ED is responsible for literally everything else. And so, it was like, yeah, I've been working at a startup. I was used to having a few hats on, right? Like we would always do a couple of things in addition to our programming, right? But here I had all the hats on, and I think the fact that I came from a really like technical background and I was very much like core Haskell community person, that was really valuable here because it made it that if somebody came with a technical proposal and said like, oh, the HF should pay X dollars to make the world better this way, I was in a pretty good position to assess that myself without having to spend a lot of time getting extra input. I did get extra input, but I could at least do the initial stink test myself.
Mm-hmm. Yeah.
But a lot of those other things were skills I absolutely did not have. And, luckily there were a number of people on the board who run businesses who could provide mentorship and help out. And yeah, so some of the things I did as the ED were, doing my best at fundraising, which was tough because interest rates went up quite a lot. And when interest rates are high, it's a lot harder to do fundraising. And so that was a nice extra challenge. But, I put on this event co-located with ZeroHack, where we got many of the high-profile GHC implementers to come and give talks about their corner of the compiler, so that we had both a room full of people who learned how to do it and some durable video information that people can watch and learn from to this day on YouTube. We arranged I set up, but did not complete. Jose oversaw completing. Jose is my successor. Arranging to transfer stackage to the HF, because that's an important community resource that should be run by the community. And by the way, if you're a company out there who uses Stack or Stackage, you should consider sponsoring the HF, because your business depends on the long-term success of Haskell and the long-term success of that infrastructure. So I'd highly encourage you to get in touch with my successor, and you're probably a programmer if you're listening to this. Talk to the decision maker and be an advocate for that. I think it's important. But then also I did a lot of peacemaking kind of stuff. Haskell isn't a sort of tightly run project. Like there isn't the Haskell project where that's like going to sit down and make all the decisions for everything. And I certainly wasn't in that role running a quite young foundation. We were going to respect people's existing work and contributions. And I think I had an important role to play in just talking to a lot of people all the time and knowing what was going on, so that I could point out, oh, hey, this thing you're doing is related to that thing being done over there. You all should have a chat. I thought that was valuable. And also talking to HF sponsors and also non-sponsor companies using Haskell, right? I mean, Haskell is much more than just industry, but it's important that we have industrial participants because we need to pay the people who write GHC, and that means there has to be money around coming from companies. And so taking their needs seriously is important, in addition to the other needs of the other parts of the community. So, and I tried to understand the challenges that people faced with like Haskell the whole package rather than with like one particular project, and then try to figure out ways to improve that, or even just build understanding and get those voices heard. So there was a lot of different things that I was doing there, and it was a really complicated job with a lot of evening meetings because US Pacific time kind of started after Danish daycare pickup time. So, put the kid to bed and then hop on the meetings. And I didn't work a completely crushing number of hours, but it was tough having the days split up like that most days. A really valuable experience. It was really difficult, where I did the best that I could to have a good impact. And, happy to see Jose really I think doing a great job running things now.
You said you had to learn some things in that job. What is the one that impacted you the most, or was the hardest for you to catch up with?
That's a very good question. Let me think for a sec. I think the thing that impacted me the most was seeing the reality behind what seems to be internet rhetoric. And this isn't a concrete skill, but having a lot of conversations with a lot of people in a lot of different circumstances that, everything from, people teaching courses with the language, to people using it in very big companies, to people using it in very small companies, to people doing it for the sheer love in the evenings after work. A lot of times we get caricatures of the other community members, or we don't take their concerns entirely seriously. And as individuals, it can be hard to see over these fences. And I certainly had my own background coming into this. And I think the most important thing was learning more ways of seeing the world in the process of building empathy with all these people.
That is beautiful. That is very nice. Warm, heartwarming answer. I like that.
But also, it's also something that I'm trying to bring on in Lean here, right? I mean, people are like, oh, Lean is going to take over Haskell. It's not. It's a very different kind of thing, right? There are basically 0 projects where I would consider which of the two to write them in. It's very clear which one I would want. And it's not that I would pick one for all projects either, right? So don't get me wrong there. But I think that given that we have the goal of making our financing sustainable over time, that means that we need to be providing value that people want to support. And I think that, having some of these lenses means that I'm better placed to at least have, internal conversations that represent certain points of view that I wouldn't have been able to have insight into in the past. So I think that's not just heartwarming, it's also strategically useful.
Nice. Yeah, very good. Very good. And I usually think like that. Sometimes we work very hard on something and we pick up some not necessarily direct skill towards that thing. And maybe we can see in the short term that maybe this was useless time, but it's never useless time. We don't know how these skills are going to be useful down the path.
Yeah. Oh, one more I got for you.
There you go.
I also learned the value of paying people to do stuff. So in my life in the past, for a lot of my life, I didn't have a ton of money. I sort of moved along and wasn't a student anymore. And then I got a little more comfortable, right? But still, I'd be and most of the time when I was in a work context, if I wanted to pay for a thing, I got to go to the budget people and be like, oh, can I do it? And we have the conversation. And that's why I wouldn't do it very often, just because, not that I always say no, but just having the conversation was emotional overhead that was tough for me.
Mm-hmm.
But, working at HF, getting all of our videos subtitled, finding the person who was good at that was so much better than doing it. We had a part-time person helping out with various administrative stuff, and it was amazing. She was so good, and worth every foundation dollar we paid her was absolutely more than worth it. And we're at the start, I was oh, can we pay someone? Yes, we can. Do it. Because the opportunity cost is so high.
Yeah.
And learning to think in that way was really, really valuable as well.
I'm starting to feel similar right now with my podcast because most of the time that I spend here is actually doing the editing, which is not necessarily related to what we are actually doing. The bulk of the thing is the conversation, the planning, and reaching out. So I'm trying to raise some money and pay someone to do the editing because that will allow everything to flow so much smoother, right? So I definitely relate to that. That's very nice.
Yeah, when we did Type Theory podcast, for every hour of recorded material that we posted in our feed, I spent about 8 hours in Audacity.
8? Oh, okay.
Yeah.
A little more lazy. I spent 2 or 3.
Or you're better at it. You've put out a lot more episodes than we ever did, right?
But yes, it's a lot of work. That's the bottom line. It is a lot of work to edit, yes.
Also, I think the tools are better today. Back then, we're doing things like going on the internet and ordering a USB headset to be delivered to somebody so that they won't be talking in their laptop speaker.
I wish I had that money, man. I thought about that because sometimes, yeah.
It cost, in the case I'm thinking of, I think it cost me $16 to all in all for a cheap USB headset.
Oh, okay. You were going for, okay.
And that was so much better than the laptop mic that it made my editing life so much easier that it was absolutely worth the $16. And I don't know where I was going with that. I just lost my train of thought. But
coming back to the Haskell Foundation, do you remember by any chance on the top of your head how many developers works on the JHC?
It's tough because there isn't one organization where almost all of them work.
How is it organized?
Yeah, so I mean, GHC is an open source project that is run according to the traditional ways of doing that. There's a few companies that have full-time people working on GHC, and those people participate in the project. It's very much like, people who might be working on, I don't know, what's an example? Like people who might be working on, like OpenSSL. Like there's people contributing to that from a variety of paid companies, like the Linux kernel. Like, some people work at Intel and send patches, some people work at Microsoft and send patches, and they work full-time on it because it supports the business needs of that company. But, the project is still only going to merge it if it's good. So I don't want to forget somebody here by accident and hurt any feelings. If I do, I'm sorry. But, so Well-Typed does a lot of work on GHC, and some of that work comes out of like a sort of general GHC fund that companies contribute to that allows them to pay people to do a lot of the normal open source stuff. And some of it comes from specific consulting things where a company wants GHC to be better in a specific way, and then they might hire a consultant like Well-Typed to take care of that. But the JavaScript backend came from IOG. The WebAssembly background came from Twig, from full-time developers who they have paid to work on GHC. There's also people who do a lot of substantial GHC work, but it's not kind of their only thing. Like, Obsidian has got... I know I'm missing people. I apologize. But those are some of them.
How is the decision made of what can be kind of merged into the mainstream GHC? Who holds that power?
Yeah, so last I looked, I'm a little disconnected for a few months now. Last I looked, it was Matt Pickering and Ben Gamari and Simon Peyton-Jones were the decision makers at the end of the day, and then they would delegate certain subsystems to people who were knowledgeable about them.
So it's kind of like a board, some kind of committee.
Yeah, and Matthew Pickering is the one doing most of the day-to-day leadership management stuff.
Okay.
Last I checked.
Uh-huh. Cool.
Yeah, and like actually one of the things I did at the HF was I like encouraged them to be more explicit about this structure so that people would know that, because that's an interesting question that's important.
Yeah.
And this was all something that like you knew if you were part of the project, but you didn't if you're... But now they've got a document in a repository that explains all of this stuff, so...
Okay, there, yeah. I know that there is a document, a paper of the history on programming languages about how Haskell came about. I love that paper. It's like, there's some conflicts that happen in the middle on how to gather people together. And one of the guys that did lazy programming didn't want to join. It's a cool paper.
Yeah, that's fun. It's also, I think it captures like an important bit of the Haskell spirit, which is that, like the propaganda about Haskell is like, oh yes, we're doing math. We're doing pure functional programming. There's no side effects. This is all so safe. Our compiler is magic. And then like the actual reality of it is that it's like, there's a lot of like extremely egregious hacks that are highly appreciated by the community. And like, we want to make all the hacks safe, but we don't have a culture of like, no kludging ever, right? Like we have a culture of like, oh, that was cool. I didn't know it could do that. And like if it's valuable, then we find a way to like actually give it a typing discipline that makes it make sense in the long run.
Yeah.
But like oh, let's put some safe course and see what happens is like a legit thing that we appreciate in the right context. I think that paper uses the term anarchic ferment at one point.
Right. Yeah.
Which does a great job characterizing some of those community values the Haskell people have.
One thing that I noticed is that back then, when Haskell was coming about, there was a lot of research going on lazy programming languages, and it feels like it was a hot thing back then. Everyone was talking and wanted, like, this is the next big thing. And nowadays, I feel that has waned a lot. And like we look at lazy programming, it's like, there are some researchers that even go all the way on the other direction to say that this is completely wrong and we shouldn't be doing things this way. What is not necessarily your opinion, but how do you, talking with people and being in that community, how do you see this perspective on lazy programming nowadays? Are people still excited about that? Do they frown upon it? Like, what is the overall feeling over there?
I don't want to make myself a spokesperson for the overall feeling. I can tell you my read of the trade-offs. I think laziness is super interesting, and it enables a lot of really interesting idioms. It makes things more compositional in some ways and much less compositional in others, right? So more compositional in the sense that if you, like, let's say you're writing some Kotlin code, for example, and you want to, take a list and do and like, iterate over it and like transform the elements and then like add them in this way and this kind of thing. Like if you then implement that by composing a bunch of functions, you're going to traverse that list one time for each function. Whereas in Haskell, you won't, right? Like so from that perspective, the functions will compose nicely. As a consequence, like the Kotlin collection API has, filter map and a bunch of like special purpose combinations of things that are frequently combined so that they can be efficient. And strict languages in general are going to, at that startup I was working at, our language front end was all in Haskell and our runtime system was all in Kotlin because the customers wanted to run the thing on the JVM. And so that worked well for us. So that's the last strict language other than Lean that I've done a lot of work in recently. But yeah, so it's less compositional in the sense that your space consumption is no longer something you can reason locally about.
Mm-hmm.
Because whether or not a thunk gets forced becomes like a global property of the program as a whole. So, non-compositional things are challenging to work with because you have to work with them empirically and using rules of thumb rather than purely analytically and locally, because any non-trivial program is too big to reason about analytically as a whole without breaking it down. And so I think the most one reasonable position to take is that laziness is awesome because, we can write our programs in this beautiful way and put things together. And there's certain things that like, when you graft it on, it's super ugly. You've got to add like a thunk type and use some mutation. And then there's the other perspective, which is that we want to reason modularly about space usage. And so is problematic. They both got good points. I think that one way in which I have outgrown my programming language hipster phase is that I'm no longer inclined to say this is the ultimate way, the narrow path along which all shall tread. Yeah, laziness is cool. One thing that's really underexplored is programming languages that are explicitly based on call by push value, where we can combine these two things without having to privilege one of them as the fundamental thing that's going on. I'd like to see more of that.
Oh, that's what call by push value is about. Can you tell us more about it?
I can do so poorly. Yeah. In that it's a while since I read up on it, so I'll probably get terminology wrong. So I'd like everybody to please bear with me here. The basic idea there is that you've got two kinds of types. You've got types that characterize values and types that characterize computations. And these sort of corresponding basically to the call by value fragment and the call by need fragment. Or to the strict and the lazy fragment. And, so you've got operations to go between them. So you've got a suspend operation, which takes a program that would compute something of a value type and just gives you that as a computation. And then you've got force, which will then, run the thing and give you the value. And the other way around, if you've got a computation, then you can, force it to get the thing out. And there's like some beautiful way that I don't remember the details of, in which these form like a nice adjunction and it all fits together really nicely. And, like when you make a function, like the body of the function is a computation, and then that it all just like works out very nicely. And then you get to be lazy where you want to be lazy and be strict where you want to be strict, right?
Yeah.
Like one of the really big benefits of laziness, in addition to the sort of small scale composition of time usage, is that you can talk about a computation without affecting it, without like poking it and getting the value. And this means that you can write things at a higher level of abstraction much more conveniently. And you can always like put a lambda unit around a thing in a strict language, but that's a noisy encoding, right? So if you want to like program with like monads as an API rather than as a tool for denotational semantics, then laziness is nice, and if you want to like talk about computations, it enables a whole way of looking at things that's just too inconvenient if you don't have laziness by default. And I think call by push value lets you do that, but also it lets you do strict programming. Frank is a cool example of a language with effects and call by push value explicitly built in from this paper, do.
Oh, that paper. Okay, yeah.
With many a pun. That's a fun design. And there they actually use the syntax of braces to implement to suspend things. The pun there being that braces is UK English, what we call suspenders in the US.
Oh!
Which are those straps that hold your pants up or hold your trousers up if you're from the UK.
Okay, gotcha.
Lots of glorious puns in that paper, as one would expect given the authorship. But yeah, like Frank is a nice example of how some of these things could look.
Very nice.
Have you also seen lenient evaluation, like in this new verse, or it's a verse calculus that they're developing, I think at Epic Games, Simon Peyton Jones and some other Haskell people are working on this.
Yeah, so I read the paper and then I forgot most of what was in it. So I forget what they mean by lenient evaluation in that one, unfortunately.
Yeah, I mean, the paper does a few different things. Lenient evaluation, it's this really interesting kind of third thing between strict and lazy evaluation because, oh gosh, I'm not going to be able to recount it exactly on short notice. But the idea is that if you have some kind of expression, with lazy evaluation, you're not allowed to start evaluating it unless the variable gets used somewhere. And with lenient evaluation, you're allowed to go ahead and start evaluating that thing. All expressions get evaluated, and kind of like you can do it concurrently. Has this weird, fancy semantics. But I guess maybe if there's not enough material there to talk about, we can cut that out.
Then the thing I thought was fun in Verse was seeing like features from Icon getting used, and I think it may be independently reinventing it rather than being inspired by Icon. But I've got a soft spot for Icon in my heart because that's what we used at the course at ITU that I TA'd a lot for, like the undergraduate programming languages course, to teach continuation passing style, because like the most straightforward way to do an icon interpreter is to just have a success continuation and a failure continuation and manipulate them in the ways that you have to make everything go through. That was cool seeing some of those ideas coming up again.
Mm-hmm.
Cool stuff. But talking about interesting Haskell stuff, there's also dependent Haskell that is kind of well, I feel that it's never completely completed. Like we don't have complete dependent Haskell, but we have some sort of many kinds of dependencies in Haskell, for example, JDTs and things like that. And I've seen that you've made an experience report when you were at Galois with the tools over there with Crucible, and saw that uses a lot of the craziest features that you have in Haskell. So my question is, what is the value of using these extremely powerful types in your language in a software? What was the value that Galois saw in this, and how does this help to build a good project?
So I think in the context of Haskell, the value for most people is probably not there. Like trying to write AGDA code in Haskell is usually not a good idea. Like it's cool that you can do it, and I'm super impressed that they've made it possible based on the original design of the language. Like that's an amazing technical achievement. But I think that highly dependently typed programming is a poor fit for most teams in most places today. This may change over time, but like I don't think as a community that we're like good enough at knowing the right ways to do it for it to be something that's like low risk enough to make business sense most of the time. But Galois is not most companies, and Crucible was not most projects. I wasn't there when Crucible got started, but I did work on it at some point, and I helped write the paper. We sorted the authors alphabetically, which is why mine comes first. It's not because I did most of the work.
Oh, okay. I thought you were the first author.
Like, it's not because I did most of the work on Crucible itself. I think I did like more work on the actual paper than the others, if I think back right, like hour-wise, but it was definitely like a team effort. The whole thing was. And a lot of that work was like, less, here's the thing, and more, integrating the parts and a million proofreading passes and all that stuff. But, so, what we say in the paper there, which I, is that first off, the value we got from using from like these really fancy types was that we just couldn't make a lot of mistakes, right? Like, this is a system used in verification workflows. These things are difficult to test effectively. There's a lot of like little fiddly things you can get wrong with like variable scopes and that kind of stuff in like the guts of a symbolic simulator that could make it compute wrong numbers in ways that could be subtle and difficult to capture. And so, the propaganda of the fancy types in our case happened to be fairly true, which was there's a lot of mistakes that we didn't have to write a million tests for, that we didn't know how to write a million tests for. Another bit of value that we had was it was super fun, which was something that's important at Galois, is that we put a lot of emphasis on like doing things in ways that people find enjoyable. Like we're not wanting to we're not going to only do that. Like it still has to work and still be practical. But like if you got two practical ways to do a thing and like one of them is more fun, then do the fun one sometimes. And then, there were absolutely costs to this approach, right? So Haskell being not designed to do dependently typed programming, there's it's not so easy to do all the time. So I found myself writing Idris code in my head and then like hand compiling it down to Haskell, much the way in the computer architecture class I took as an undergrad, where we were like doing MIPS assembly. At one point, I'm like writing C code in my head and like hand assembling it rather than sort of thinking natively in terms of MIPS, because otherwise it was too hard to think about. So I had like an Idris program in my head that I could realize in a Haskell program. And then it was okay, because then the compiler helped me keep it okay. But like actually producing it ahead of time, I don't think I could have done in another way. Probably some people can, but I couldn't. And like that makes it a hard skill set to recruit for. Also internally at Galois, like there were a lot of people who had a hard time working on that code base simply because of all that fancy stuff, compared to like Cryptol, which was, a fairly conservative code base that didn't use many fancy things, and the fancy things it used were, ones that were easy to explain. Also, it introduces a lot of brittleness, and brittleness in the sense that it's hard to make big changes because you can't just change one bit, because then you have all these type constraints you have to propagate through everything. This is great if you want to do some consistent refactoring of small, well-understood thing. This is not great if you want to tweak a thing and get it done. And so this brittleness can be good or it could be bad. Like this is a business trade-off rather than like a thing that's good in and of itself. But most of the time, it often isn't that good. I think in our system, the spec was evolving slowly enough that it worked out. But for most systems, that's not the case. Yeah, like if we could turn back the time and write it two ways, it would be really cool to see actually what the actual trade-offs for this thing would have been. But we can't, right? So, yeah. But we made it work, and we got value at the time. I don't know how the thing is going today. I hope it's still going well.
Having worked so much with dependent types, with teaching, with an overview of how the industry is going for functional programming languages, how far do you think dependent types can go into the mainstream, in the sense of, okay, so Crucible is definitely an example of how dependent types is slowly getting into the industries, giving some value for these companies. Do you see one world where, I don't know, like a crazy world where we will be hiring developers for developing proofs for our programs in this sense? Or how do you see the adoption of dependent types in that sense?
So I think there's two questions hiding in your question. One of them is what seems to be likely from the perspective of doing formal verification of software using dependent types as a logic to prove things about programs that are otherwise mostly simply typed. And the other is working with indexed families and data structures that embed invariants during the course of programming to get things done. And these are actually two quite different activities, even though they use essentially the same building blocks. Or, the extrinsic and the intrinsic approach is what people call it sometimes.
Right.
I think the first thing to think about when you want to get something adopted is, how do you make it easy, and how do you look at all the stuff surrounding it? Because it's not so much the specific bit of tech. It's, recruitment, and recruitment comes after education, because you can't recruit people who don't know how to do the thing. And, education requires a certain amount of maturity of tools so that students can figure it out and so that hobbyists can figure it out. And all of this also means that you have to have a mature engineering discipline, which is something that functional programmers in general aren't good enough at, in my opinion. I think Mike Sperber is the one to talk to on this stuff. He's putting in a lot of good work to help get us to do that. I remember back in the day when the design patterns book was the hot stuff.
Yeah.
And all the Haskell people were we don't need design patterns because design patterns means the visitor pattern and we can just write maps. And I was also taken in by that rhetoric to an extent that I'm not proud of today, because I think it was actually really misunderstanding the point, which is not that the visitor pattern is knowledge for the ages. It's that certain things are not going to be handled well natively by your language and your tools.
Yep.
And those things will, sometimes you can just make a library, but sometimes you're going to make 3 libraries and they'll have some things in common. And part of being a mature user of something is knowing what those common patterns are, both so what things have worked out well for others, and also so that others can use your thing without having to learn everything from scratch. And what that design patterns book did really well, that we should not have ignored in functional programming, was saying this is the kind of problem that gets solved in this way. Now we have a name to talk about it. And here's how you do it right, or here's how you do it in a way that has worked well for a lot of people at the very least, if not absolutely right. Mike Sperber was using a really good example of this, which was like a combinator library. Like what are the principles for making a good combinator library? Write them down. You can't, because we haven't done a good enough job as a community, like prioritizing doing this kind of work. But there's this like functional programming architecture workshop co-located with ICP. Like progress is being made now, which is good, and there's more people paying attention to like the domain design movement, which I know exists but don't know the details of, so don't grill me on it. But people I trust are like, this is important, pay attention, so I will try to. And this kind of stuff is a prerequisite to industry adoption of anything at all. And like some people will say like, oh, this is too hard for industry people, they can't hack it. And that's wrong, right? Like people said that about higher order functions in the 90s and the early 2000s. Today, people like higher order functions was that, oh, just functions? Like that's the normal thing, right? Like it's just like completely universally adopted by everybody, and like nobody bats an eye because we know how to tell people about it. But it used to be considered like a difficult idea that you had to like put time into, right? Like Lisp people were like, yeah, closures, like, that being the data structure that implements lexically scoped functions. And they were right to say that because it's a useful thing, especially if you have mutation, you can encode all sorts of cool stuff. But, like today, like nobody's like, yeah, closures, because like, that's like saying like, yeah, parsers, like we don't parse our language with regular expressions. Like, of course you don't. And we need to get there for either use of dependent types. And so we've made some progress on the programming with index families for this, and a lot of progress on the extrinsic verification thing. I think the extrinsic verification thing is like, there's a lot of really good patterns out there. People know about like proof by reflection. They know about how to do various kinds of solvers. They know how to do various kinds of automation. And the real problem there is just that it's too expensive. And the way we make it cheaper is by having better tools. And, there's a lot of progress going on. I don't know how fast that progress is going to go. I'm trying to do my small part on the documentation tooling side to push it forward. It's good that we have multiple languages and multiple implementations out there, because then we'll do different stuff and we can learn from each other. I think like viewing this as like some sort of like battle royale is dumb. We should view this as like, we're friends and we're walking along together in slightly different ways, and let's help each other out.
One win, everyone wins. Any kind of thing you are able to push forward in your language will bring also traction for our language. I also think that way, yeah.
Hopefully. And like the design space for dependently typed programming is huge, and we've only mostly clustered in one little corner of it, which is a pretty good corner. But, there's also a whole lot of work to be done on like, what if we make the equality judgment be this other thing? And I think one of my favorite episodes, I don't want to say that. An episode of our podcast that I really liked. I don't know what the favorite were. They were all so much fun.
They were very good.
But like we had this interview with Stephanie Wyrick on
Zombie.
Yeah, Zombie. And they're like, they've got a very different notion of equality, which let them do all sorts of cool stuff. And, the book is absolutely not closed on this in the future. And, all these little details matter a lot for the practicality of using a system. And we're just not done exploring yet. But when it comes to like doing verified software development, I think, the path to adoption is not, let's make this language and get everyone to use it for everything. It's like, let's make this language good at a thing and then make it like affordable to do. Like CompCert is so much more expensive to develop than a similarly performing C compiler that isn't verified. Like, what if it only costs twice as much? That'd be cool. Or like, having developed it, how can we use it to make the other C compilers better?
Right.
There's a lot of questions of ways to approach things. Amina Torlak's group at AWS has used Lean in a creative way recently that I think is a pretty compelling way of using it, where a problem where verification made sense, which was something, security critical, where the specifics of the like formal model matter a lot for the correctness of it and thus its value as a security tool. But they needed to go fast and they needed it to be made with tools that work well in their organization. So they wrote down their spec in Lean, did a verified implementation in Lean. They proved the meta properties of the spec in Lean. They then, proved that their Lean implementation satisfied the spec, the meta properties being all the various things that had to be true for this language. Then they wrote an optimized Rust version, and then they used a fuzzer and they put a fuzzer in their CI that makes sure the two agree, or like tries to find ways they disagree, and if it fails, then success. And then they can deploy the Rust version, which is like faster than the Lean. Like the Lean version is pretty fast actually, because Lean has a nice compiler. But the but the ROS version was a bit faster. But also they had people on staff who could like fix it if it broke in the middle of the night, and they could like fit into their auditing infrastructure. I don't actually know the details of the business. I just watched her talk, but it's a cool talk. You should, if you're listening to this, it was part of Lean Together, which was this online Lean conference we put on earlier this year. But for whatever, for all the reasons they needed to not have Lean and running in production, they could do this. And I think that's like a really cool model that a lot of organizations could use to get value out of these things in this period where it's like valuable enough, but not so compelling that you want to do everything with it. And maybe we'll never get to where you want to do everything, and that's okay. As long as like we're doing a lot of cool stuff, right? Like Haskell exists, C exists, Rust exists. That's good. You don't have to prove all the things. And as far as, I really think that like that maturity is much more there for this extrinsic verification stuff. I think we could see that, like, if the current progress on better automation in all of these systems continues, I could see that, getting a lot more popular in the near future. But that's a guess. It's, as far as the program with index families, like, that's something that when it works well, it works really well. Like, I was really impressed by Edwin's representation of the core terms in Idris 2, which is self-hosted. Like, and there Idris 1, like everyone listening to this who has not ever implemented capture avoiding substitution should go do it. It'll be wrong.
Yeah.
And then you'll fix the bug, and then it'll still be wrong in some subtle way, and then you'll fix that bug, and then like 6 months later, someone will be like, yeah, it's wrong. And you'll be like, it's just really, really hard to get right.
Sit down and try to prove that in your favorite theorem prover. It's super hard.
Yeah.
Super hard as well.
Yeah, I mean, that's even harder than implementing it correctly, is proving that you did so. Yeah. But, he used index family to track the variables, and what he says is that, like, these bugs just don't happen anymore. Kind of like our experience with Crucible there. But, like, I think Idris is designed to do dependently typed programming rather than having it added on through a heroic effort like in Haskell. So I think that it's easier to do there. But, I think an approach that often works well is to like use the fancy indexing as like the internals of a library, and then provide a more simply typed API to it that like checks the invariance at the boundaries.
Yeah.
So like the incoming thing, like, check that we can represent it the right way. So like parse it from the simply typed tree to the dependently typed tree. And then if that succeeds, then like pass it off to your library where no further validation needs to be done. That seems to be an approach that people have had success with. But like putting it everywhere in the program is a thing that I've heard a lot of stories about things not working out.
Yeah, I can see that.
I hope we get better at it, but I think that we just have a lot more knowledge to figure out how to make that something that works well, or if it can be made to work really well in a lot of situations. So it's like some wisdom is needed still for this one.
I really like that idea. I like the answer. Well, so to close the episode, thank you so much for being here, David. It was a very nice conversation. I think we all learned
it's been fun
so much from you. You have such an upbeat energy. It was very exciting.
That's because I'm sitting here drinking tea, and it's like, caffeine in the bloodstream in the evening.
And dude, isn't it midnight and midnight 30 for you or something?
It's like 10:30. I'm fine.
Oh, okay. So
I'm gonna hang up with you and then like see if there's any last minute household chores and hit the sack.
Good luck.
Yeah, but it was really great. I love talking to you. It's really fun. I wish that my Esperanto was not so rusty that we couldn't do this in Esperanto, just to give the
same for me, dude.
The listeners an extra treat. That would have been super fun.
Mi dankas vin vian prezenco or something.
Bone. Mi forgesis tre multe.
But as we were talking a little bit offline, you will be coming again. We'll get a little more technical next time, hopefully within the next month. So I'm really looking forward to that. Thank you so much.
That'd be great. Yeah, we could dig into some bidirectional type checking and using Lean as a programming language as well as a theorem prover and all that fun stuff.
Quotation, quasi-quotation, things in Lean and Idris. That'd be fun as well.
I always like to like dig out some like book on analytic philosophy from 1954 and throw it at the programmers, right?
Well, we could also get more into the philosophy of things as well, because now that you mentioned that you're a philosophy major, which I didn't know, right?
I'm really out of touch with that community, so I'm not going to have a whole lot of useful stuff to say. But I mean, many of the most fun ideas in programming languages have their origin in analytic philosophy, and also to an extent in continental philosophy, right? Like, I mean, the 1954 joke, that's quasi-quotation. That comes right out of Quine, right?
I have no idea what is all of that.
Oh, Quine. WVO Quine, one of the leading philosophers of of language and
Oh,
super influential.
oh, okay, gotcha.
He invented quasi-quotation for the purpose of describing logic.
Okay, gotcha.
I think 54. I got the book somewhere.
Huh.
And like Martin Löw cites Husserl, and so there's a lot of important things that we have learned. But I also feel like the connection is less strong than it used to be, and probably the philosophers are doing cool stuff that we could make awesome new ideas in programming languages from. But
Well,
I just don't know what they're doing because I've lost touch with the field. So we got to find some philosophers and grill them.
Dan, do you have any closing remarks? Thank you so much for co-hosting, by the way.
Yeah, no, it was such a pleasure to be with my two podcasting heroes. I'm just this is the dream podcast listening experience, basically.
Oh, thank you. Yeah, thanks so much for having me on here. I really like doing this kind of thing, and it's maybe not the best thing in the world to enjoy hearing yourself talk, but
You get
I kind of do. So when I show up and I get to sort of tell stories about things I enjoy, I get my old man on the porch vibe going, and it's a good time for me. I enjoy it. I hope other people enjoy it too.
That's it. Hope you guys enjoyed this episode as much as I did. David is such an upbeat person. It was such a cool conversation. We are organizing to make part 2 happen. This is the end of April, and we still didn't record the part 2, but that's gonna happen. So stay tuned. Well, if you have any questions or comment about this episode, send them to our email, typetheoryforall@gmail.com. If you have any suggestions, I'm very open and glad to hear from you. Also, consider joining our Discord. We have a channel where we hold discussions about each one of the episodes. And of course, don't forget to donate. Any amount will be greatly appreciated. Go to our website at typetheoryforall.com, and any amount, any $5, we already pay a coffee. And I'll greatly, greatly appreciate, because I love coffee. Well, so that's it. Thank you so much for staying until this point. Have a great time.
Este podcast foi editado por Play Áudios.